All right, reaction rates can either be sped up or slowed down by several factors. So if you want to control that speed at which something is occurring, there are some things that a scientist can do or that can happen to speed it up. This is based on collision theory, and collision theory says that for molecules to react, they've got to collide or bump into each other at the proper angles. And there are factors that can speed up or slow down these reactions. I want you to think about collision theory for a minute. Some of you have ridden the bumper cars at the fair a few weeks ago. And if you went to that ride and it was just you and your brother and there were only two of you around that track, sure, you collided into each other, but you didn't, it wasn't constant. I mean, you could only go so fast, you could only catch up with each other so many times. But if every car had somebody in it and driving around that track, then there were lots more collisions. So the more molecules that are in the given space, we call that concentration. So if I want to speed up the reaction, I would use a very concentrated form of the chemicals. It would not be diluted at all. If I want to slow it down, I would dilute the concentration of my chemicals by adding water or rubbing alcohol, some other solvent that would just dilute and spread out the molecules. Think about chlorine. Chlorine is a poisonous chemical. Pure chlorine would kill you if you went swimming in it. But if you add just a cup of chlorine to a swimming pool that holds hundreds of gallons of water, you have diluted the chlorine, and it is not, you can go swimming in it safely and it will kill the bacteria. But the pure chlorine, the concentrated version without any dilution, would kill you. So concentration, how many molecules are in a given space. Temperature is another factor. If I want to speed up the chemical reaction, I'm going to add heat. If I want to slow it down, I'm going to take heat away. So food science is a great indication of temperature in speeding up or slowing down the reaction. If I leave food out of the refrigerator, if I cook dinner and have leftovers and I leave them sitting on the stove, by the next morning there's going to be bacteria in that food and it is going to be decomposing it, and very quickly it is going to rot or become unsafe to eat. So by leaving it out and letting it stay at, say, 70 degrees in your house, I'm going to speed up the decomposition reaction that will occur with bacteria in the food. However, if I want to slow it down, I can put those leftovers in the refrigerator and they will last for several days. I'm going to slow down the rate of decomposition. Helps keep the bacteria off the food, and then it will slow it down. And many foods can stay in your refrigerator safely for weeks at a time. Another is surface area. If I want to speed up the reaction, I'm going to smash a solid chemical into many, many small pieces. If I want to slow it down, I'm going to leave it in a very large piece. Now, if I have a really bad headache and I want to take some aspirin for my headache, I can take the 2 tablets and it'll take about 45 minutes for digestion to begin occurring and get that aspirin to my bloodstream, and then another 10-15 minutes before it starts to reach my head and I get any relief. So up to an hour. Now if I take that aspirin and crush it into a powder and I swallow that powder, it's going to be absorbed almost immediately and I'm going to get some relief in about 10 or 15 minutes. So I can speed up or slow down the reaction by changing the surface area. The fourth thing you can do to speed up or slow down a reaction is to add a catalyst or an inhibitor. And a catalyst is an extra substance that's added to the chemical reaction. Its molecules do not get changed in the reaction. It just either speeds it up or slows it down. So the yeast acts like a catalyst to hydrogen peroxide. We're going to do a lab in a few days where we're going to use the iron in blood from a piece of raw liver to catalyze a reaction and let it happen in about 3 minutes instead of about 10, 15, 20 minutes. So we can see the results in the class period. Food it's often any products you buy that are packaged has an inhibitor added to it to slow it down. And so an inhibitor does the opposite of a catalyst. It's a third substance that's added to the reaction. It has no change. It doesn't get changed like the molecules do when the chemical reaction takes place, but it will slow down decomposition in food. So like Twinkies, for example, if you made a cake with the same recipe for Twinkies and sat it out on the counter, it would begin to mold because of all the sugar in it within just a very few days. But yet the enzymes that are added to the commercial cake cause it to slow down that rate of decomposition. It won't begin to mold. You can leave it on your shelf for months, even years, before it would begin to decompose. So temperature, concentration, surface area, and catalyst or inhibitors are things you can add to a chemical reaction or do to a chemical reaction to change its speed.